Hello, everyone. These days, we've started talking quite a lot about how software is transforming manufacturing facilities and how a lot of the value creation in manufacturing is now shifting towards digital space. So we've decided to have a bigger conversation on that topic. Because there is many different solutions in today's manufacturing. So we'll be trying to decipher how those different packages, how those different types of software are defining modern manufacturing. That's why I gathered many experts in the field. So we have Christian, Simone, Oliver, Sebastian, who are experts in their respective fields related to specific software. So what you will be seeing today are discussions from the data analytics in the factory through how the digital twins are reshaping how the manufacturing is done, up to even, what you can actually achieve with robots on the factory floor when you augment their functions with software. So it's going to be quite interesting conversation, I hope. And let us start. So as a kind of introduction of what I am saying and how software is creating new value, I think that you couldn't start with a topic different than AI. And there is a lot of buzzwords around AI. And of course, it will have many different shapes in every factory. But maybe we can start with an obvious example, how AI is nowadays changing manufacturing processes. So, Christian, could you give us some details?
Sure, Piotr. So, many manufacturing companies are exploring how data science and AI can help them to discover their full potential of their shop floors. A key challenge is finding new personnel and new operators and qualified personnel. So the question is, could human knowledge be transferred into an AI-driven solution that maybe supports the operator's decision-making? Companies are looking at how machine learning can transfer knowledge from experienced operators to less experienced staff. They are realizing it doesn't require complex, expensive systems.
Right. And that's, in my opinion, quite interesting example due to the fact that it's a completely different type of information that you have to process, right? So we'll be going into details how all those different information will be transformed by software. But another example for me, and what is changing quite a lot in manufacturing, are the intelligent components. So what I'd like to ask you, Oliver, is what kind of different value those components deliver these days on the factory floor.
So we have the AI technology implemented directly in our robot controller. So the software inside the robot controller can analyze the data autonomously and adjust parameters automatically. Yes, this gives the operator a big advantage with an easy and fast setup. It for sure reduced dramatically the commissioning time. And the idea of this AI software inside the robot is that the robot learns to react, to work like a human. So which means optimizing the process by getting experience, by learning. And this happens inside the robot controller directly. So we don't need an external PC, which is often needed. That's the big advantage, that we can offer it inside the robot controller directly.
I think that this already gives us quite interesting picture where, first of all, the components are generating much more data in the past. Then the types of information that factories have to process are also changing quite a lot. So I think that this already gives us this first big trend in the industry, which is related to the masses of data and many different types of this data. So I think what I could ask you, Sebastian, is how do you see this change in manufacturing happening? So all of those factories that are generating massive volumes of data, how do they handle this situation?
Yep. So basically what we are seeing is we're seeing a fundamental shift from focusing on the physical process itself and moving towards a full data management approach, because there are the last few percentages I can use to optimize my processes. We are well automated nowadays in a lot of regions. So that's how you generate more or create more value to your process chain and increase your insights. For that approach, there are digital platforms just like Genesis, for example, that are connected to all kind of sources, no matter if it's OT, if it's IoT, or if it's IT somewhere in your server infrastructure. We're collecting the data, we're processing the data. It's not only aggregated, but also historized and then analyzed for the future. And yes, so that's a massive amount of data that is handled there.
Right. So for me, this sounds very much that this has become type of a standard in manufacturing, that it not only get a lot of data, but nowadays you are kind of forced to already know how to process it to gain the competitive advantage. So, Christian, would you agree with this statement, and how do you see it with, let's say, customers that you work with?
Yeah, I see definitely the same trend, and I agree with Sebastian. So this transition is happening across all industries and about all company sizes as well. So we are seeing this, of course, for large automotive manufacturers, but also small to medium-sized enterprises are basically looking and embracing digitalization in all different aspects, because the barriers to entry have decreased significantly. The technologies have become more accessible, more user-friendly, more scalable, and I think companies can start with a clear focus on, for example, a specific use case like predictive maintenance on a critical machine or a critical component, and expand as they see results from this first learning period. And this gradual approach reduces the risks for the customer and also allows for learning at the same time.
Right. But those things, those changes are very much relevant across the life cycle of the business. So Simone, I think we've discussed in our different conversation some topics related how the implementation of automation is changing. So maybe could you give your insights from your experience how the software can modify the approach to system planning and implementation?
Yes, of course, Piotr. Digitalization is changing the entire life cycle of the machine. So before physical installation, we can create a digital twin, a digital model to simulate, test, and optimize the entire production process. So this is the first assumption. But this design work, let's say, through digital tool, through virtual commissioning tool, reduce dramatically risk and cost. And of course, potential issue can be recognized before the physical construction on the machine. So we have a more robust solution from the day one.
Mm. So we already see there is a lot going on in different fields, in different, let's say, company functions. And I think we should try to tackle this one by one to create kind of like a big picture of how those software packages are transforming the production. What I will be trying to do next is to, go through all of those major technologies that are modifying the approach to the usual manufacturing methods. And I think, again, we couldn't start with anything else than AI, because it's such an important topic these days that, of course, it creates the most impact in manufacturing among other businesses, of course. Christian, in this case, could you maybe sum up how artificial intelligence is changing the approach to usual data analytics?
I think, first of all, it's important to understand that AI transforms raw data into actionable insights. The key difference to traditional analytics and AI-driven approaches is that AI can actually detect patterns or correlations that humans might miss. So especially if there's really complex data sets with machine data. With MyLab, we have a tool where manufacturers can detect anomalies in the production processes before they lead to quality issues or to equipment failures. The system learns what normal operation looks like and then flags deviations that might indicate developing problems. What's really valuable about MyLab for customers is that it doesn't really require some data science expertise, because we have a tool called the AI Data Scientist function, which is basically guiding the users through all these different steps to create the analytic model, to find patterns in the data. And then finally, we have this tool as a competitive advantage for normal production engineers and maintenance teams, that they can use this tool without specialized training.
Right. And I think it's worthwhile to mention that this kind of AI-enabled, of course, edge-level data analytics, I think it fits very nicely the big topic of, digitalization as the trend in manufacturing, which means that digitalizing processes means actually acting on the data, and AI is, let's say, the most powerful instance of this approach. But I guess the digitalization doesn't stop with the data analytics in the field. So maybe we could discuss also the bigger scope of how those software technologies are enabling digitalization. So maybe Sebastian, you could share your experience with this topic and how this kind of bigger issue of the digitalization is handled with proper software.
Yeah. So first of all, maybe it's helpful to just say a word or two about how we typically approach these kind of projects. So with Genesis, we have a digital platform that we use to set up the foundation for all kind of analytics in the first place. Basically it enables all these applications that we are discussing today, because it collects the data, it centralizes the data, it normalizes the data because it's coming from all kind of different sources. And on top of that, I can start to do my analytics, whether it's AI enabled or some basic statistics in the first place. So we're creating an enterprise environment for data, basically. We are able to connect to all kind of different sources that we are bringing together. No matter if it's a PLC, if it's a robot, if it's an inverter, if it's a meter, whatever it is, we're able to bring in the data, to pull the data into the platform, and then use these information for our applications like OEE analytics, for energy management to reduce our consumption or to fulfill sustainability goals. So in general, to break down information silos. And that's exactly what our customers are usually looking for, because normally they have a lot of information available, but they're all stuck in all kind of different silos. And that's why we bring in a platform that opens or breaks those silos.
Sure. But then again, the digitalization doesn't stop with the data, right? Because, I mean, data, usually it's already let's say, a non-physical object. But the digitalization is these days also transforming the physical equipment, and digitalizing actual hardware is happening. And I think this brings us to digital twins, which are a very important part of this big picture. So Simone, how do you see, from your experience, digital twins to be important in this big picture that I mentioned?
Yeah, of course. First of all, let's define what is a digital twin. A digital twin is a virtual copy of an asset, a process, or a system. And as we said, it's transforming all the phase from the design, implementation, and optimization of the machine. Let's say that during the design, what is changing is that the user can check the layout, verify the workflow, so the user can spot a potential issue like space constraint, for example. And at the same time, you can simulate material flow, the operator working on the line, and you can calculate before the physical asset exists also the throughput of the line. So this enables also the what-if scenario. So what if, how would changing a process parameter affect the productivity of my line? Answering to this question before to build the real machine, I think that this is the key point that the digital twin will touch.
Good. So when we think about digital twins as virtual representations of physical assets, obviously robotics comes to mind immediately, as those are those devices where, you know, planning the movement of the robot virtually is definitely helpful. But I'd say that digital twins are not the only software type that changes how robotics applications are done, right? So could you outline, Oliver, how do you see changes in the, let's say, approach to robotics thanks to software?
Yes, for sure. Software is now changing what's possible with robots. So you know, mainly the industrial robots have I would say, dedicated, more complex, more complicated programming style. So you need to write code. But now we see more and more intuitive programming tools for the robots. So intuitive means visual programming tools. So it's like you make a box, a block with drag and drop. You make the sequence of the robot's movement quite easy. You need only to change parameter of the block, but to have the flow chart, it's much easier. For sure, it's opening also new, I would say, capabilities of using robots at end users. They can easily change, for example, easy pick and place applications without writing a lot of code. Also the software in the robot controller giving us a more dedicated force control, vision, implementation, where the software inside the robot control can detect a lot of things with the camera and automatically calculate the movements. So it's finally optimizing the usage of the robot, but also giving advantage and easier startup, easier commissioning for the operators to use the robots.
Right. Definitely, and this is very much visible in all those trends related to how easy it has to be to program a robot, to make it flexible for today's production that is often high mix, low volume. So for sure. However, like till now, we are discussing all those different technologies a little bit separated from each other, each one serving a specific purpose. But if they are going to be useful and powerful in majority of factories, they have to fit together. So I'd like to discuss a little bit how you create a integrated software solution that is able to support the transformation process in a holistic way. So I'd start with digital platforms which can serve as this kind of integration point, because factory-wide operations being monitored and visualized with digital platforms seem like something that creates this kind of full integration of data, assets, and also different chains, engineering and supply chains and so on. So how does Genesis serves as this kind of integration platform?
Yeah. So basically, we see Genesis definitely as an integration platform. That's because we adopted very early in philosophy what we call universal connectivity. That means we have all kind of connectors available using standard protocols, standard communication to integrate the data from IT, from OT, and from IoT. So that's, for example, OPC-UA, that's could be BACnet. BACnet is in the building environment, could be Modbus, could be an MQTT, could be a REST API, could be web services, could be a direct database integration. So basically and that's all predefined, ready to use, no scripting needed, etc. It's there, you just have to connect your devices. From there on, you just pull the data from those devices into the platform where it's managed, as I stated earlier. By saying that, of course, we can also integrate our other software packages, just like Gemini, just like MyLab, etc., to even increase the level of information of new insights that we are generating. And we can even take the next step and manage those new insights, because at some point there will be a huge load of new insights somewhere in the future coming from AI tools like MyLab, coming from intelligence components directly. They have to be managed, and that's basically what we do, and provide these information then as a role-based information, because a machine operator wants to have another view on the data, on the new insights, than a general manager, for example, in his enterprise level or enterprise reporting level.
We're often distinguishing one big centralized platform, like what Genesis can provide, from those local solutions, like on the edge, with edge level data analytics. But then again, even if edge technologies can work kind of in an independent way, they still fit this integrated ecosystem, right, Christian? So how does this edge level analytics fits in this picture that we are now explaining?
Yeah, based on what Sebastian just mentioned, MyLab serves as the bridge between raw data and actionable insights. So we have Genesis as this data collection platform, but really where the power of all our combined solutions is that the power emerges when these technologies work in layers. So it all starts with a connectivity layer, with a network to enable the data flow, data collection systems on top, but then the analytics layer, where MyLab tries to find hidden patterns or anomalies of that data. And these insights can then be fed again back into, for example, a platform like Gemini to simulate improvements. And this will lead to optimized parameters that are then deployed back into the physical system, like robot or like servo drives, or in general, an automation system. So think about my lab might analyze the process data from multiple sensors, some IoT parameters, and we identify factors correlated with quality issues, for instance. Now, these insights can help operators that are actually working in front of a Genesis dashboard to recommend some adjustments of process parameters to them and to trigger, for example, maintenance operations before these problems occur. So this ecosystems of solution is definitely a big key advantage that we are offering to customers.
And I think you mentioned a very important point about how the actual field data insights from data can be fed to the digital twin, because a very important point that you're also making is that digital twins are not only relevant for the initial stages when you are planning the production. They are also important during the process of utilizing the actual equipment. So Simone, maybe you can build on that point that Christian made, and how maybe you can explain how Gemini as a digital twin is complementing this kind of approach.
Yes, of course. Building on what Christian described, let's say that Gemini integrate a temporal and a spatial dimension to the data, while MyLab, for example, explain what is happening and why. Let's say that Gemini visualize how the process unfold to a spatial dimension and over the time. So, for example, it's very valuable when planning production system changes, because you can integrate a CAD, so replicate your line, your production line, and simulate how the changes are impacting on productivity, but taking into account the time, taking into account the workflow and the physical constraint. So this is a real added value to the digital twin. And in general, it facilitates also the communication between different teams inside the same company, because everyone is looking at the same 3D representation. So the communication between technical and non-technical team is now easier.
So all of those things that we are discussing already paint a quite interesting picture. So we are talking about technologies where you can take specific decisions already on the component level or on the edge level, report those things in integrated data platform where further decisions can be made and further optimizations. All of these links to virtual representation of the factory. So this is already, for me, this factory that is able to utilize all of those functions is already very, very advanced. But maybe we could discuss about the future. I think everyone is always interested in how those things will develop. Therefore, maybe we can think about how all of those value items that we have discussed will evolve in future, and how you could depict the future factory. So, Sebastian, what's your take on that? How do you see the future of, let's say, fully digitalized factories?
I think we will see very, very soon a fully digitalized factory where all the components, all the machines are connected and talking to each other, and gain more insights more automatically. So already today we're talking about cyber-physical solutions or systems that are connected with each other. So by by those internal connections, we will have as a result a more automated process, and as Christian stated earlier, like an automatic replacement of failures, of issues, etc., that can be handled directly by a software agent, and basically support to keep our processes alive or in best shape.
Right. So yeah, we are talking about kind of autonomous approach already. So for sure, that's one of mega trends that are often mentioned in various research. Then again, everyone is also talking about how robots will only going to continue reshaping the factories. And of course, there is a lot of changes in the robotics sphere. So in that case, Oliver, from your perspective, in what way further developments in robotics will change how factories operate?
I think the future factories will get much more flexible and adaptive. So the trend is going from the mass production to the, I would say, one lot production. So it's more customized. And thanks to all this technology, the digital technology, it is possible that the batch sizes are going down, and maybe the systems, the robots, servos, machines can somehow reconfigure by themselves due to the learning, due to the software, due to the external sensors, force sensors, vision sensors, which are connected to the robot. And I think this is the main trend from the mass production to small batches, that the factories, as I said, get more flexible, adaptive to the needs, finally, of the end user, of us, you can say.
Right. So again, what you're describing sounds very much like even more autonomous type of manufacturing, enabled by advanced robotic solutions. And then I think AI is only going to stay with us. Obviously, we cannot imagine a future factory that is not using AI, and I think that most of the manufacturing in future will require specific AI implementation. So do you project any changes in that regard, Christian?
Well, first of all, I think it's fair to say that, yes, I do see analytics and AI becoming more autonomous and more proactive. As it is today and how customers are deploying AI right now, it still requires human intervention to act on these insights. So it's more like a guidance system that AI can provide to operators and machine operators. But in the future, there will be more closed-loop systems to make adjustments automatically with defined parameters. So think about an AI system that might detect a process drifting towards production out of spec parts and automatically adjust parameters, or it might predict component failure and schedule maintenance during plant downtime. What is important for me to mention is, please try to stay in your field and start small, starting out by making sure you have a good data collection in place. That's the most important step that I can recommend. And start with a specific problem, how to deploy AI. You might have a predictive maintenance case, you might have some quality optimization on a high-value product. Begin with a pilot project, measure the results, have a buy-in from the management to also support such kind of AI initiatives, and build on that momentum for broader implementation of AI for the future.
Yes, I think considering the future of AI can quickly overwhelm anyone. So exactly. I think that your recommendation makes total sense for most. And then finally, the digital representation of assets, digital twins. Simone, how do you see them in future?
Yeah, for sure, I see them more integrated with the physical world, because up to date, we can say that there is a gap between the physical world and the virtual representation. But tomorrow they will be tightly coupled thanks to real-time data that flow between them. So for sure there will be more integrated, and this will enable also to dynamic optimization. This optimization will be based on current status of the machine, so on the real-time data, and this for sure will bring value. But I have just a suggestion for the beginner, because they don't have to be afraid, because they can start to replicate just the layout of an existing machine, and in this way you can have already an insight regarding the workflow and the potential bottleneck. And then as you gain experience with the digital twin, you can add more functionality and more detail.
Right. Very good. So I'd say that the key thing to remember from our conversation is that definitely a proper use of software is providing huge value for the manufacturing, but those items shouldn't be deployed as kind of like islands. They have to fit a bigger picture. They need to fit together. And in order not to overwhelm yourself with the scope of the project, it's better to start with small actions whenever there is a proper need in the factory, right? So I think that approach, that strategy will bring us to the future that you guys just described. So thank you very much for this. It was a very interesting conversation, and thanks for being here.
Thank you.
Thank you.
Thank you.